Welcome to our Zen Sand Table final project showcase. This mesmerizing device uses two linear actuators to move a magnet underneath a layer of sand, manipulating a metal ball on the surface to draw patterns on the sand in an extremely satisfying manner. Please be warned that what lies ahead are some extremely satisfying clips of the Zen Sand Table in action. Proceed with caution and enjoy the satisfying sand table experience. Here's our table in computer mode. We take an input image, such as this fish, process it into a simplified line drawing, convert the lines into a list of coordinate points, and finally send it over to the individual motors. The image processing and calculations are done using Python on our computer, and the instructions are then transferred to the Arduino via the serial port, and the motors move as instructed. Inspiration for this project came from Google searches for some cool electronics DIY projects. The sand table caught our eye in particular because of its satisfying nature, artistic expression, and its capability of having an interactive demo. The application of this project can be seen in artistic or entertainment uses, for instance as a fancy coffee table that can draw mesmerizing patterns. This is the calibration mode, which helps us reset the table by moving both motors to the designated 00 point. Since the motors do not know its position after shutoff, we use the switches and buttons to tell the Arduino when a motor has reached 0 on its corresponding axes. And the final mode, joystick mode, aka over-engineered Etch-a-Sketch mode, which takes in human input live from a joystick to control the velocity of the ball in any direction. Let's dive deeper into how the table works. The two linear actuators are stacked on top of each other, so we have X and Y directional movement. On the circuit board, the main components consist of an Arduino, two stepper motor drivers, one for each motor, and four external inputs, two for each of the switches used in calibration, and a horizontal and vertical reading from the joystick that vary based on the positional feedback of the two potentiometers. In addition to the power the Arduino provides, the motors are also attached to a 12-volt DC power supply. While the ball may seem to be rolling smoothly in this video, the project was not always the most satisfying to work on. We ran into countless challenges along the way, including difficulty with the image processing, failing to properly solder the switches by accidentally melting the plastic of one of the switches so much that it became dysfunctional, and trying to get the serial communication of the computer and Arduino to work properly. Finally, when we tried putting the sand we bought on the table, we realized that the Home Depot sand was super rough and had the ball frequently getting stuck. Since we didn't have enough time to order different sand before the fair, we ended up using one of the most high-tech solutions ever. Hand sifting the sand through paper with holes from a nail for 4 hours straight. And lastly, during one of our test runs, we were given a challenge by the man himself.
You need to try ES50. ES50.
ES50!